talk about what topics we are going to discuss in the class today. So yesterday we didn't do the 7 quality tools. That's something we did not have a lot of time for. So I'm actually debating whether to start with that or whether to do that at the very end. We'll decide, as we go. So yes, definitely we are going to cover the 7 quality tools topic today since we did not have enough time. And then today there are 3 independent topics. Again, we are back to how we used to start with the class, like talking about 1 or 2 terms and 1 or 2 processes as we go. So today we are going to talk about software. CM stands for change management. So this is, I know, another question from Tina. You wanted to know what is change management and all that from what you've seen in the test plan. So this is the time when we will discuss that. You also wanted to know what traceability matrix is. We've already covered that. There was another question about what TCOE stands for, isn't it? TCOE is generally a department that is in most organizations. So TCOE stands for Testing Center of Excellence. So they are the core group that will assist the companies in case you have any issues. So they are like the advisors or mentors. So this is like an independent group. So we had this group in my beginning organization where in any time we had any questions about how to design your profession. So I had this question where I was wondering if I should even go for a certification or not and do what. So they are the kind of people who mentors you. So Testing Center of Excellence is an exclusive department that is in most companies who will make sure that knowledge wise people are updated and they provide assistance in case they need any. So which brings us to our topic of today, which is software change management, configuration management, and version control. So these are 3 independent but integral topics to being a QA, and for that matter to being any IT professional. So we'll talk about them briefly, but the majority of today we are going to spend on defect management. So defect management, again, whenever you hear the word management, it talks about how we control things and how we formalize and establish a process to deal with a certain entity or a system. So defect management deals with first thing is, there is no general rule to how to identify defects because defects happen and we have different techniques to identify them. So once defects are identified, what do we do with them? How do we deal with them? So how do we, record them? How do we track them? How do we make sure that, work is conducted on them? At the end of it, how do we make sure that those defects are resolved? So all of these, the entire process that, has all of these subsequent or, constituent steps is what is the defect management process. So we'll spend the majority of time today on defect management, and really defect management is, if I have to rank in order how important testing activities are for a tester, the number 1 place would definitely be for test cases. The second place will definitely be for defect management. So defect management is very, very important because this is one way for us to showcase the outcome or the output for what we've been doing so far. So it's very important as a tester to understand the nature of defects and to be able to actually put across. See how we will discuss all of this when we go into next weeks of sessions, and and in the next week when we talk about how to develop the skills, how to face the interviews, we'll talk about how testers need to have 3 important basic category of skills. One is technical skills. All the 3 weeks that we've been working on in this class, we've been trying to gain the technical knowledge. The second thing is communication. Third thing is attitude. So when we're talking about communication, it doesn't necessarily mean that how well you can talk or how well you can write an email. Communication is also about how clearly you write your test cases and how clearly you do your reporting, how clearly you write your defects. So defect management plays a lot of role. And defects are not for something that, so we don't create defects just because we want to use them somehow. We create defects so we have to communicate to an external team on what is wrong. So it is very important to actually write, a very clear-cut, concise definition or description of what is going wrong, and then send it to an external team. So it's a matter of internal respect, it's a matter of the credibility, it's a matter of QA team doing its job productively. So defects are very, very important. I cannot emphasize enough on that. Finally, we have UA team. Now, my experience tells me that we probably will not be able to do UAT today based on the time, but I kind of keep it just in case. If we finish sooner, we can actually, include it. Otherwise, that's something that we'll do next week. I'm thinking I'll start with the configuration, change management, and version management. Following that, I'll do the quality tools, and then we'll do the defect management. So we'll follow that order. I think that's going to work. We'll see. So change management. Change management is an important step in all projects, almost all projects. So the change management is common to both agile and waterfall model projects. I mean, there is a slight, way in which the treatment is slightly different, but then more or less these change management process is similar for both agile and waterfall model projects. Now, what change management is let's say there is an AUT. So AUT is nothing but your software that you are testing, and this is called the AUT only when it is in the QA environment. So whenever you hear the word AUT, you will have to be 100% sure that you're not talking about the code that is present in either the dev or in the production environment. So once this is 100% tested, so when I say 100% tested, it doesn't mean 100% success. So 100% testing, 100% success are two different things. Now, once it is 100% tested, 100% success is never a reality. So there will never be an instance when this product is 100% bug free, no matter how many instances you check it for. So even if you have like 3 cycles or 4 cycles or 5 cycles, at the end of it, there is always going to be bugs. So having said that, at the end of the entire QA phase and UAT phase also for that matter, you will still end up with X number of defects. Right, so there might be 1, 2, or 3, they might be significant, insignificant, so they'll range all over the place. So let's say this version of the application with X number of defects that is going into the production environment is version 3 or something like that. So if the current version is 3 and you've identified this X number of defects. Now there are two ways to go about it. One is if you foresee a version 4 in the next, let's say in the next in a very brief amount of a future time. That means in the next 2 weeks or 3 weeks or 4 weeks or even a month. So if you're foreseeing a new release, what will happen is the new requirements plus the bug fixes for this X number of defects will become the scope for version 4. So if you are foreseeing a new release. But what happens if you are not foreseeing a new release? What happens if you don't want to bring a new release at all to this product? But at the same time, you don't want to leave the X number of defects unaddressed. So that's the scenario where change management kicks in. So here's what the scenario is again. There are X number of defects available. The current version is 3. This is already in production. Version 4, there is no scope of it. So there are no new requirements that are going out as part of it. So the version 4 is not going to happen. But this X number of defects should still be addressed. So in that case, a change request is opened up. Change request is initiated. So change request is generally called a CR. CR is a common term that you will hear in the IT world. Now CRs are initiated by the business analyst. Since business analysts are the best ones to determine whether this X defects, will cause a detrimental effect to the business or not. So if they see that, this is going to be negatively impacting, we need to fix it somehow, then the business analyst will initiate a process called CR. So when they initiate a process called CR, the first thing they do is they document the scope. So what is it that needs to be done? What kind of, work is expected? What kind of changes are we expecting? And if the fixing of this defect will affect any other modules. So all the scope, feasibility analysis, all that is done and a CR document is created. So this is nothing but similar to your FRD document, but very, very limited in scope. It will probably be 2 or 3 pages. Even 1-page CRs are not uncommon. So it will be very few things and, very few details. So there's just a CR document. So the CR document is created. Now once the CR document is created, CRs also have numbers. So this is CR for version 3 or whatever 3.1. So CRs are also given a unique identification number to actually make them uniquely identifiable. Following the CR creation, the BA will go ahead and present this CR to both the development and the QA team, and if there's any other technical team like the database team or the architecture team, design team, anybody else, if they need to know, the CR is presented to all of them. The reason why this is presented to all of these people is because development team have to plan for building of course, and they will have to also do an analysis on how the code change pertaining to this X defect fixing is going to affect the system, or whether or not it's going to affect the current system or not. Similarly, the QA team also will have to analyze the requirement, or the scope, understand the scope. Following that, we will have to plan for our testing. So when I say plan, we will also prepare a mini test plan, we'll prepare test cases, or sometimes we don't have to prepare exclusive test cases. We might have to modify the existing ones, or just pick and make a new copy of the ones that we are going to test as part of the CR. So we'll do all that preparatory activity, and then dates are decided, and then the testing is carried out just the way normal testing goes on. But so the CR testing again, so if the code version 3 was the initial version of the AUT, I mean the software system, so this will be your main code. The CR code is usually called the branch code, and then these two are merged, but first testing happens again in the QA environment itself. So just because this is a change that is happening on the application that's already gone live, it does not mean that the code changes are taking place directly in the production environment. No, the code changes will again be developed in the development environment, tested in the testing environment, and then move to production eventually. So CR is a process that gets initiated whenever a minor change has to happen on the application that's already in production. CRs are initiated by business analysts. They are documented, presented to development, QA, and all the other teams, whoever this may concern. And the development QA team, they will treat it as a mini project and start working on it, write your own tests. So we as QAs will write our own test cases, give some dates and all that. And finally, once the development is done building their code, they will add the branch to the trunk, and so this is called the branch code, and the main code is called the trunk code. Is it called the trunk, or is just a source code? It depends actually. There are different ways to address that. So all of that gets combined, and then the code moves to the QA environment. We'll again test it, and then another production deployment happens, and that will finish the CR process. So change request for all intents and purposes is just a mini project, very, very limited in scope. Any questions, team? All right, so let's move to configuration management. So configuration management, really there is not a lot to it. Now, when we were reviewing the test plan, or FRD documents and test plan documents, you would see that all of these documents will have their version information, and whether it's a draft or whether it is a finalized version, so you will have all of this information. Now, why is this information important? This is important because when you choose an incorrect version of the reference document, the chances that you are going to derive incorrect conclusions out of that is going to be really large. So to not get into that situation, usually it is recommended to check that a particular version is available. I mean, the particular version is the correct one, and that is what you should be using in order to create the next set of documentation. So this is something that is simple enough to understand. Now, a lot of times when you encounter a system error on your laptops or your computers, there is an option, if you have noticed. It will ask you, do you want to revert to the last working configuration, or do you want to fix the problem yourself? So how is it able to go back to a previously working configuration? Because the system keeps track of that. Similar situation also happens in the IT world. Now we'll take the other example. So version 3 is deployed to production. So the QA is done, and then it is deployed to production. Can we say with 100% assurance that there will be nothing wrong with the application that goes into production? We cannot say that for sure, correct? So earlier, if the version that was in place was version 2 and the version that you have, put in after whatever enhancements you have made to the code is version 3, and for some reason version 3 does not work. So in that case, you would actually have to stop the deployment process and go back. This is called a rollback. The code actually is rolled back to a previous version that we know is working. So with the deployment, always there is always a need to have a backup plan on where to roll back code, to roll back to a version that was previously working. Now this is a case that is common. I mean, this is actually a backup plan that all companies will have, all software systems will have. Now how does anybody certify that the previously working version was so and so? It's actually the QA team which keeps a note of what the previous version was, what features it had, if there were any issues, known issues in that code. We are the ones who keep note of every version history. Now in some companies, when there are huge projects and versions go in every 1 or 2 days, there might be a special configuration manager to make sure and to keep track of all of this version history. So in an IT world, never will code get discarded. So even though version 3 might be version 2 plus some new code, correct? So that doesn't mean that version 2 is not going to be existent. So a different version is created, I mean a different instance is created, and then that is updated. So this is actually something that I recommend for my teams as well. So when you have like a test plan document, you're going to make an update on it. Do not overwrite your previous test plan. Keep a copy of that, create a new instance and make your changes, update the version, make sure how you tracked your history. Sometimes this is very important because, see, we think we are communicating, we think we are letting the project manager know how much time it's taking. So what happens if they are not paying as much attention to that and there are discrepancies at the end of it? We must keep a documented trail. And we must make sure that all the documents and versions are all in place and we know what they are. So this is what is in short called the configuration management. Now configuration management applies to code, to documents, to database instances. So anything else that will change over a period of time is a good candidate for configuration management. But as I said, in big companies, there might be an independent configuration manager, but for smaller companies, the QA has to work as a configuration manager from time to time. The next thing is version controlling. If you have any questions, I'll take them at the end of this. So version controlling is related to configuration management. So we are talking about keeping an instance of all the documents and everything. But where? How do you actually maintain that? So to do that, there are softwares that make this possible. There are tools actually, version control tools. Now these version control tools are like Visual Safe and there are lots of there are lots of version control tools. But the simplest example that I can think of is the Google Docs. So if you create a spreadsheet, for one, you can restrict the access. So you can actually, decide who can do what on this document. So who will have the access, and even though, they have the access, you can set the levels of access. Some people can just read, some people can edit. Some of you will not be able to access it unless you have the link. It's a private document. So all kinds of restrictions exist. So version control document will store all of your documents, will store all of the code, anything, any artifact that you're trying to version configuration manage. That is something that you can store in your version controlling system. So version controlling system is nothing but a centralized, oftentimes browser accessible repository. So it's just like one centralized place where you can upload all your documentation and restrict access to them. And to further actually make sure that you have you can keep a track of every change that is happening to the document itself, there is a process called check-in and check-out that is an inbuilt activity with the version control tool. So let me explain what that is. So let's say I'm creating my new test plan document and I have uploaded this to my version control software. Now when I upload, the document is checked in and the version will become 1.0. And let's say team member A has checked this out. So the document will not be you will not be able to edit this test plan if you do not check it out. When you check it out, you will be able to edit this document, and until then you'll only be able to access it on a read-only mode. So once you check this document out, after you make all the changes, you can the version gets updated. So here the user has a choice to either update the number after the decimal or the number before the decimal. So if it's up to you. If you feel like it's a major change, you can change it to version 2. If it's a minor change, you can actually change it to 1.1 or something like that. So after checkout, you can edit. After check-in, the version changes again. Now let's say person A has checked out and B is trying to check out the same document. That is not going to be possible. The document will only be available in a read-only mode. Unless A checks in, B will not be able to edit this document again. And this version controlling software will maintain all the records of who checked in at what time, what kind of changes did they make, the older version. So if you want to revert to an older version, you can do that. All of these options are available in the version control software. The reason why I include this topic in the class is because most of the time we are very proficient in our technical information. I don't know if I told you this instance recently or not, but one of my friend, he finished his MS, and the other day he was like, look, I mean, I think I told you already, but I'm going to say that again. He found a job immediately after MS, and he did really well. He was a SQL developer. He still is a SQL developer. Everything went great, and I asked him how's your work one day, and he tells me that he just is not able to perform because they use a software called Team Foundation Server for all the managing requirements, managing test cases, managing everything else, and he has always been learning the SQL development part but did not know how to manage the work. So when you go real time into IT projects, it's not only important to know the QA concepts, but to know all these supporting concepts that are around. So version controlling, work management software like Quality Center, TFS, all of that. It's very important to know those things. Otherwise, I'm not saying that we are not going to learn on job. We are, but to go prepared is to actually go, being better educated and better informed about things. So version control is definitely something that you'll all be using, if not already. If you want to get some practice, go to Google Docs, create a document, share it with your friend, see how the versions get changed, and from now on, whenever if you're using a smartphone and if the app applications or apps, they come for a version update, take a look at that. There are lots of details that you will get to know from all of that. Take a look at, pay attention to how the version numbers are getting updated. So there are 26.3.4 point something like that. So see which version was previously coming, which version is coming now, and what's new, what is different. So it's a lot of there's a lot to learn in that area. So that's version control. So yeah, this is the 3 topics. Are there any questions, team? All right, which testing phases do these activities belong? Now, change management is something that happens after the application goes to production. So it does not happen within the STLC phase, it happens outside the STLC phase. So this is just a mini project that may or may not happen after the project goes live. So this happens after the testing cycles are complete. So it will not happen in any of the phases. But version controlling and change management are like background processes. They could be happening in basically any stage. So see, for example, you want to version control your test plan, so that can happen in your test planning phase. If you want to version control your test cases, that can happen in your test design phase. If the developer wants to version control their code, that can happen in the development phase as well. So the change management is something that happens outside the SDLC, but configuration and version controlling are like, parallel processes that go within. And sometimes we might not even consciously realize that we are doing configuration management or version controlling. So these are like intrinsic activities that are very much part of our day-to-day things. So for every change management project, yes, it will be a mini project. The planning, designing, execution, everything will be carried out. Yes, that is a great observation. Thank you. All right, if there's nothing else, we'll move to 7 quality tools. A fair warning here, this is actually very, very theoretical, and the use value of these tools is very less. But the reason why I cover this in class is because sometimes knowing these 7 quality tools is important, especially if you're preparing for certifications. And also sometimes the Pareto chart that you're seeing on my screen, there are few interview questions around that. So we'll not leave any stone unturned, so we'll just cover that briefly. Although I must tell you that I'm not going to go into the mathematical calculations on how these charts are drawn, but however, from time to time I have come across students who are interested to know how cumulative frequency is calculated and all that. So if you are interested academically on how this is all done, I would suggest that you get in touch with me offline, and I'll help you make those computations. But the reason why we don't cover that in the class is because it's not important. Like as I said, real-time use value is very less. And I don't want this to be an overwhelming or cumbersome experience. I just want to keep it light and fun. So that's why we're going to learn the concept today. But if you want to know the calculation, I'll help you with it, or just send me an email and we'll take it offline. So let me give you a little bit of a context about what these 7 quality tools are, why are we discussing, and where do they even fit in. Now these 7 quality tools are, frankly speaking, if you search for the 7 quality tools, these go way back into the Industrial Revolution. So these are like few techniques or few tools that are in place for us to do various sorts of things like problem solving, root cause analysis, identifying patterns, and so on and so forth. Now, where do this really fit in? One area that these can fit in, again, I'm not going to generalize, briefly might be in the status reporting. There might be some statuses that when you generate in the report or pictorial form, it might make a better impact. But not all quality tools are conducive or are supportive for the status reporting. So these 7 quality tools are not exactly IT related things. They are things that relate to common any business that is conducted where you're trying to do any problem solving or do any root cause analysis and all that. So the 7 quality tools, to start with, it's the Pareto chart, and this is where most questions come from. Now, more than the chart, more than the diagram, what is important is to know the concept of this. Now the Pareto principle is also called the The Pareto principle is also called the 80-20 rule. So 80-20 rule, it just means that, let's say if you have an overwhelming number of problems, okay, we all do, correct? So during the building of a software or during testing when you have a lot of defects, whatever it might be, you might have an overwhelming number of problems that need to get solved. And these problems might be happening because of few causes, right? And ideally, you will have to tackle 100% of the problems and tackle 100% of the causes. So you'll have to actually go ahead and handle all the causes, which in turn will fix all the 100% of the problems. But in case you do have a crunch of time and you cannot address all causes, then the Pareto chart says that you will have to identify those 20% of the causes that will fix 80% of the problem. So here, instead of 100% of the causes, we are actually optimizing it to picking out only 20 of them, but at the same time, ratio wise, we are fixing a lot more problems See, we are not actually addressing 80% of the causes, but only 20% of the problems are not getting addressed. So let me give you a real-time example. Again, I probably will not be accurate, but will try to do my best. So let's say if the project has defects, lots of defects. Let's say there are 100 defects that are identified and they have to be fixed by the developer. And there are 5 modules in your application. Now these 5 modules are the causes, correct? Anywhere in these 5 modules, these 100 defects might be there. So ideally, you will have to work on all modules, fix all of them to fix all 100 defects. But when you don't have that much time, Pareto chart tells you to choose 20% of these problems, which is approximately one of these causes, one module, which is most flawed. If you fix that one module, it says that 80% of the problems can be solved. Now, how far is this accurate? That is, time and again, it has proved to be accurate. I mean, of course, I would believe that. I do not have first-hand experience on that though. But the way Pareto chart is drawn up and is used for this 80-20 rule is this way. So I will just maximize this so you all can see better. So as you can see, this is just a simple bar chart. So if you assume that the x-axis, the horizontal line, to be the causes. So first of all, it is ordered in the decreasing order. So this is module A, let's assume, has 5 defects. Module B has 4, module C has 3, module D has 2, module E has 0. So A, B, C, D, E, sorry, this one has 1. So has all of these defects. But you don't want to fix modules A, B, C, D, E. You want to choose only the ones that will address most of the issues. Now from this diagram, it is very clear that if I just fix one, A and B, it will fix most of the problems. But in some cases, assume that it is not that apparent. So initially, a histogram is drawn up, and then the line that you're seeing here is the cumulative frequency graph. So you will just draw the, you'll just plot a frequency graph, and then there is a cumulative frequency graph. Now this chart is used, the analysis in this way. So following at the 80% line, this line is drawn onto the curve, the cumulative frequency curve, and this is directly dropped down. So anything that falls in the x-axis between 0 and here, that is modules A, B, and C, those are the 20% of the causes that will fix 80% of the problems. So if I fix these, I basically will be fixing like close to 12 issues. So this is the 80-20 rule, and it is, this is normally used in cases where it is not apparent which causes, when we fix them, will result in maximum causes being maximum problems being resolved. Are you all with me? So 80% of these effects come from 20. Yes, correct. So the next thing is the cause and effect diagram. So this is much simpler, and I'm sure most of us have studied this in school. I don't remember if I have. I'm assuming I have, but if you can remember, maybe we did study this in school. Cause and effect diagram is also called an Ishikawa diagram or a fishbone diagram. So this is because the Japanese was he a scientist? Maybe. Ishikawa has actually either created this diagram or made it famous, depending on which book you read. So that's why it's called an Ishikawa diagram. And it's called a fishbone diagram because of the way it looks. So this diagram is used in problem solving or root cause analysis basically. So this tool is also retrospective in nature. That means this will not tell you how to foresee a problem. This will actually show you a problem that has already identified, and it will has already happened, and it will show you what has caused the problem. So let me give you an example that is as close to IT as I can think of. Let's say a project got delayed. Project delivery, you were supposed to deliver, in the month of January of a certain year, and you did not deliver it until March. So there's a 2-month delay to this project. So this is the effect. This is the problem that we are trying to figure out why this has happened. So the problems might be because of the people, the team that you chose. They might be because of the process that you chose. They might be because of the technology decisions that you've made. They can be because of, money, budget not being available. So these are the main causes I'll just draw up. And then what went wrong in the people area? So 2 people quit in the, critical time of the project. You picked out the wrong attitude-based people. Attitudes did not work. Maybe geographical separation did not work. So all of these are the reasons that you'll figure out. Similarly, if there are any process-related problems, you'll just go ahead and write that. Now, the way to use this tool eventually after it is being created is anything that has the maximum branches was the problem that created most, detrimental effects. So this is how this tool is used. Mostly this is a brainstorming tool. So this is something that cannot be created by one person or one person's interpretation. So if it is just about one person, I can sit and think about it and just, conclude that, hey, this is why this happened. So these cause and effect diagram is actually a brainstorming tool where, when things go wrong, all the concerned parties sit together and, on a whiteboard probably just draw it up and, come to some conclusions and maybe follow it up with some corrective action. So, but this is the root cause and effect diagram. And practically, if you ask me, I have never used any of these tools, so I probably will not be able to tell you how much will this be used or anything, but I actually see a little bit of a use value to this. So if you do need to use it, it's easy enough to create and it's effective enough to actually work. So I think cause and effect diagram has a lot of potential. And definitely think along the lines, if in case in the future if you get a chance to implement, try it, if not for anything, to evaluate it. So the next diagram that I have is the scatter diagram. So this is for understanding the relationship between 2 entities. So I'm trying to think of an example that is as close to IT as possible, if possible the QAs. Let's talk about environment and the number of defects. So let's say the QA environment is inconsistent. That means sometimes the database gets connected, sometimes the database does not. Sometimes the results are retrieved, sometimes it's not. Sometimes the web server is up and running, sometimes it's not. So there are lots of environmental related issues. So when environment inconsistencies are large in number, what is the effect on defects team? Do you think the number of defects is greater or lesser? Greater, clearly greater. So in this case, if we think about number of environmental inconsistencies and number of defects, they are 2 things that are directly related to each other. But let's assume that we are working with 2 entities whose relationship is not as clear as it is in this scenario, and you're trying to understand how each one of them affects the other. So in that case, scatter diagrams are used. Now, how scatter diagram works is, on day 1, if the environment went down like 10 times and the defects encountered were, let's say, 30. So you will actually record these details over a period of time. So let's say 10 days. So over a period of time you'll do this. So 10, 30, 20, 15, whatever, 30, 12, so some random numbers. You'll do this for a period of 10 days. And after that we'll plot a graph that is similar to this one. So the x-axis would now be the number of environmental inconsistencies and y-axis would be the number of defects that you encountered. So as environmental inconsistencies grow higher, the number of defects are also going higher. So this graph shows us that the relationship between environmental inconsistencies and the defects is directly proportional. If for some reason, if you ended up with a graph this way, so as x-axis, the value on x is growing, the value on y, if it's decreasing, then you can say that there is a negative relationship between those two entities. And if you end up with a graph like this or this, then there is no relationship between those two entities. So this is in place to show whether or not multiple entities in a system, they have any special relationship with each other. Then is check sheets. The example, yes, the best example I could give is the environment defects and the system defects. So was that example not clear? Because I'm really trying to think here, and let's see. Okay, I'm going to think about this, Sandhya, and before the end of the class, I'll let you know. Okay, one more. We'll get one more. So check sheets. Now, check sheets are a tool that you can use where we want to record the occurrence of a certain event. So check sheets are really very informal, and this is something that you can actually, try and implement. So if there were some number of unexpected computing errors on a certain day. So let's say you belong to the help desk, and a certain thing has failed, and you got a call on day 1. Every time you got a call, you'll just make an entry here. So at the end of the day, you'll just check that off and make a total. So this is just to record the occurrence of any event over an extended period of time. You can use it for identifying the number of processing terminations. You can actually use it for number of defects. You can use it for how much time it took for you to run a particular program on over a period of time. So check sheets, again, they're very versatile. They have a lot of use value. It's nothing much. This is just a simple table where you just mark the occurrence of every event with a line or a dot or anything like that, and just calculate or add them up at the end of the day. And then is the histogram. Histogram is the simplest, and this is something that we can definitely use in our status reports. So let me show you. So if you will have the modules to an application, and you would have number of defects. So let's say if in the admin module, you've identified 5 defects or 4. In the dealer module, if you have identified 6 defects, and in the user module or visitor module, whatever that is, there are 9 or 10 defects. So sometimes, yesterday when we were talking about status meetings, we talked about how you can either send an email, or in some cases you can actually invite everybody to have a stand-up meeting where you present the status. So when you're presenting the status, it is very important to have some visual aids. So to do that, one of the commonly produced visual aid is the histogram. So you just take that, and there is your histogram. So it's very simple, very, very visual. It will show you, if you want to color code these based on the module, you can do that. So all of that is possible. So this is just a simple bar graph where you will show, what is the progress and all that. And then there is the control chart. Control chart is used for determining process maturity. So what is process maturity? Now, one of the easiest examples I can think of in this scenario is the test readiness review checklist. So we use this to basically determine whether or not we are ready to go ahead with testing of the subsequent the test execution phase or not. Now, can I say with absolute certainty that every time I use a TRR, I will not miss out on anything? I will not miss out on checking anything that I need to look for. So can I make sure that this works 100%? No, there are no guarantees. There might be things that I miss out on. So anytime a process is newly implemented, we kind of, make a list of deviations. So the first time you used how many things did you miss out? So let's say I missed out on 12 points. Again, that is too much, but just for the sake of an example. The second time I missed out on 0 things. The third time, something might have changed in the environment or something else, and you had to like incorporate an item which you failed to do that. So there might be 3 to 4 deviations there. So over a period of time, all of these deviations are noted out. Now we cannot set a very optimistic target that TRR should work 100% every single time. So we establish ourselves lower control and upper control. So lower control we can probably say is 3 until you can have at least 3 defects. I mean 3 things that you might have missed out, and the upper limit probably is like 5. You don't want to cross over 5. So 3 is okay. I mean 0 is best, but 3 is okay. Anywhere between 3 to 5 deviations is okay. So this becomes your lower limit. This becomes your upper limit. So over a period of time, when you identify these deviations, you will plot these into this kind of a line graph. So there is a lower limit and there is the upper limit. Let me yeah, so you'll do this. So anytime, let's say when you plot this graph, if there is something that goes over or something that goes under, it means that something is wrong with your process itself, that you will have to revisit the entire thing, rewrite it. Something is really very wrong with how you're implementing it, and then you'll have to go back and revisit it. So control charts are actually used to see how well a particular process controls the system and controls a particular activity and ends up giving you accurate results. So that's the control chart. And lastly, we have the flow chart. Flow chart is something that you're all very familiar with, but then I'll show you one that we have already seen, which is the test plan. So anyways, we have to look at the test plan today because this is where we are going to talk about, this is where we're going to get details on how to perform the defect tracking and all. So this is an example flowchart. Flowchart uses these help of different kinds of symbols to denote different things. Usually the rectangles are all processing squares. The rhombus or the diamond shape that you're seeing, that is basically for decisions, and then the shape that you're seeing is for start and stop, and this shape, I think it is when you reach to a conclusion or a result. So these are used to yes, sorry. So all of these shapes are used to denote different kind of activities that are happening. So all flowcharts start with a start, and then the processing that happens next is that the tester will report defects, and the next step is that the tester will validate the defects, and so on and so forth, and here the decision is made. So when the tester retests the product, is it approved? If it is a yes, the decision is made that we have to close the defect and the process stops. Otherwise, the process goes back to further processing in the development lead. Now, flowcharts are used whenever you will find flowcharts mostly in your technical design documents, where they'll try to tell you how data flows within the system, and they might be used in this case also, like in the test plan or something. So these will help you understand the flow of systems and how one process leads to another, what kind of decisions are to be made, so on and so forth. So this is also a kind of how do I put it? This is also a kind of tool that helps in understanding things better. So this is a visual aid that helps in putting things in a better perspective is all. So those are the 7 quality tools, team. There is the Pareto chart, the 80-20 rule, the cause and effect diagram, the fishbone diagram, which is a really good brainstorming and root cause analysis tool. Then there is a scatter diagram that can help you identify if there's a relationship between 2 entities. So for example, you're wondering that there is some knowledge concentration in the team. So this, I'm coming up with an other example for the scatter diagram. So there's person A who everybody believes is the expert, and everybody believes that without this person A, the project is going to fall short. So this is a team of size 5. So what you want to do is, day 1, when let's say team member A is not present. You want to make a list of tasks that are done. So A is not there, but still on day 1, if 10 tasks are done. On day 2, 20 tasks are done. Day 3, 30 tasks are done, so on and so forth. And you'll also plot another graph where A is present. On day 1, they were 15 tasks done, so on and so forth. So you'll now draw a scatter diagram and see how the presence of A affects the team or not. And if you end up with a chart that looks like this, that looks like the positive chart, that means the presence of A is very important, and without that person you're actually dealing with um, A is important, and if person A is present, a lot of tasks are done. But if person A is not present, is present and still it does not affect the number of tasks, you probably will have a negative relationship. I don't know, this probably is an example that will confuse you more than explain it better. Well, let me think of a better example. I'll probably email you on that, Sandhya. Check sheets are basically to record an occurrence of a particular event. Histograms are bar charts to denote, frequencies and how things occur. Control charts are used for processes to measure, how mature a certain process is. And then flow charts are used to denote data flow and the flow of events in software systems. So those are the 7 quality tools. Any questions? So yes, again, if you have any questions, or if you are interested academically to know how these charts are drawn and how these graphs are reached at, feel free to let me know and I'll be able to help you with that. So let's go to the defect management, which is basically the main topic for today. Now let's go back to, I think, day 2 or day 3 when we were discussing defects, very new. What is a defect? So let's start from the beginning again. What do you think is a defect, team? It's a bug, yes. So it's a bug, error, issue, problem, fault. So all of these things are bugs. In some cases, they're also called cases or incidents. So these are basically different ways in which you can address or in which synonym words that you can use in place of the word defect. Now defect is nothing but any deviation from expected behavior. Yes, which is exactly what Manish is saying. It does not match the requirements. Now deviation from the expected behavior could mean that there is an extra requirement, there is a missing requirement, there is a requirement that is not working as intended, there might be an environmental issue, there might be a document related problem. So all of these are issues. So basically anything that basically an issue does not necessarily have to be about the AUT. If you have anything that you want to bring everybody's attention towards, that also can be an issue. So what I mean to say is, we understand what why missing requirement is an issue, correct? We understand why extra requirement is bug. Incorrectly working requirement is a bug. And then environment issues are a bug. So environment issue does not necessarily mean that something is happening or something is wrong or anything like that. So when environment goes down or when environment is not being consistent, you really need to grab somebody's attention in order to have that fixed. So it doesn't necessarily have to be about the requirements. If there is anything that you need from an external team in order to go back to testing effectively, that also is an environmental issue. So the reason why environmental issues are also raised as defects is because of this. Let's say on a certain day, the database is down from 9 a.m. to 11 a.m. Now when the database is down, can the QA team fix it by ourselves? No, we will have to get in touch with the database team. So the database team has worked 2 hours of their time, and the QA team, let's say it's just 3 people, have wasted 3 times 2, that is 6 man hours. Right? I wouldn't say wasted, but we were actually waiting on it, correct? So we are actually there is actually 8 hours of work. That's almost a day's worth of work that went on into this, whatever it might be. Now in IT, in an IT world, it is very important to show accountability, to show, where things went and where time went. Unless there is a defect raised, unless this work on this defect is shown, there will not be any measurable, quantifiable, tangible, traceable, entity to which we can say that this is what we worked on. So in the best interest of time management and to actually make sure that the accountability aspect is carried throughout, we actually raise a defect for every environmental inconsistency that comes up. That's point number 1. The second reason why we raise an environment defect is because in this 2 hours of time that took for the database administrator to fix, they will, if there is a defect, you can add to the defects history and say that what corrective action was taken. Because let's say this defect happens again, you don't want to reinvent the wheel, and you don't want to start one more time again and all that. So that's why when you create a defect, there is enough history evidence to back it up, and there's also a legitimate location to record your lessons learned or corrective action, so that the same thing can be used for future references. So environment defects are definitely defects, and anytime you face an environment inconsistency, make sure you record it. So what all is included in the environment? That's a good question. Anything like, if the browser is not working, if the application is a 404, so any kind of a failure becomes an environment issue. So environment consists of, multiple things, at least, 3 things: the client, server, database. So if any of one of these components or all of these components, they are not working as intended, that becomes your environmental issue. All right, then if you have any enhancement suggestions, if you feel like, this site could be better if we add this one small feature, then that also is something that you can raise as a defect. And then finally, documentation inconsistencies. So if there's any issues, or if there's anything that's written wrong. See, this morning I was consulting for a firm, and we were actually doing a sprint planning. So I do corporate training, so I was doing just the same thing, and there was a BRD document, and it's a healthcare application, and in the BRD document it was written that doctors will have access to the appointment information. Now this became such an objectionable point, because doctors, why should they have the appointment information? Why should they have the patient's SSN and all that? It is the hospital management system that should have. So finally the consensus that was reached was that the doctor term should be replaced by provider. So you see, documentation inconsistencies can be very crucial, and how do you deal with them? How do you make sure that they get tracked, traced, and eventually fixed is via a defect. So when you raise a defect, you're kind of like signaling with a red flag saying that, hey, this is where something's going wrong, we need you to fix it. So it doesn't exactly have to be related to the AUT. I mean, the defect doesn't exactly have to happen on the AUT, but around that also becomes an issue as well. So all of these cases are legitimate defects. Tina's question is it a network or hardware related? Both, actually. So if the network is inconsistent, you still cannot work. If the hardware is broken, then there's no chance of working. So anything that prevents you from working is an environmental issue, and it's happening because of a hardware or a network issue, then definitely both of them are environment related. Now, how do we find defects? That's a good question. So enhancement suggestions are also related to AUT. right? So one enhancement suggestion that I get over and over from all the batch members who work on Car Guruji is that when I log in as an administrator, if I want to see the featured cars page, I will have to actually, see, for example, I'll show you a simple thing. I'm here, I'm setting the featured cars that needs to be displayed on the home page. I'm setting them as the featured cars. Now I don't have an option to go back to my home page, but I actually have to relaunch my page or close the existing page, whatever I need to do in order to get to the home page. Now wouldn't it be nice if there was a home link right here so I can just go and take a look at that? So that is an enhancement request. So that's something that you're suggesting, that's a function to be included in the application in order to make it better. So that is definitely pertaining to the AUT again. Now incorrectly working requirement, that you already say that it's a incorrectly working requirement. But if it's a missing requirement, so this can also be a missing requirement, correct? That thing not being there. Let's say if there's a requirement document that says the home page link has to be there and it's not there on the AUT, that's a missing requirement. So this also is related to the AUT. Now extra requirement is, for example, instead of setting as featured cars, I also had a reset button which will basically, uncheck everything. But the reset button is nowhere mentioned in my BRD. So the presence of the reset button will be still on my AUT even though that's an extra requirement. So extra requirements will also be present on your AUT. Incorrectly working requirements clearly on your AUT. And also environment issues, sometimes they get reflected in your AUT itself. For example, I'm trying to retrieve country management list and the list does not come up because the database is down. So I see a 505 servlet error or some sort of an error. So sometimes environmental failures, they might show up on your AUT or they might simply result in a 505, page cannot be found error. So we cannot rule out the possibility that environmental failures are not shown on AUT. So maybe on the AUT or not. So documentation inconsistencies clearly are the only things that we will not be able to see on the application under test. Make sense? All right, so take your time with that, Emilio. Let me know if you have further questions on that. How do you report this? We'll come to that in a minute. So extra requirements are only seen by testers. That's no, that's not that's not a generalization clearly, but testers are the only ones who look at the application as keenly as real-time users would do. So if nobody else has found it, then we would. So again, which brings me back to the question of how do we find the bugs? So you were telling me we run tests. So does this mean that we use the test cases? Yes? Maybe? Yes. On the other hand, not for everything. Yes, I was getting to that. Do you think we should, if you are not using a test case and you've just, found a bug. So right now, let's say the home page not being there, I have actually not used any test cases, but I still found that it's not there. So I found it while I was exploring the application. Do you think that's a bug? So whether or not there is an existing test case for a particular, functionality, a bug is a bug, whichever way you find it. So either you can follow a strictly documented based testing, or you can do it exploratory way. Either ways, when you find a bug, it is a bug. So defects do not have to arise from an failed test case. They can actually, not belong to any test case also. So exploratory testing also will result in bugs. Now, what do we do once we find these bugs? The next step to finding these bugs is to first report the bugs. Now, a few pre-steps that I would recommend doing when you find a bug, especially when you're new, is to do some analysis on the bug. First, determine if it is really valid or not. See, the reason why we have to try and report only valid bugs is because, see, when you raise a defect, what are you doing? You are actually, the QA team is actually creating this bug, taking time to, include all the steps and everything, sending it to the QA lead for review. And let's assume QA lead also has overlooked it. And then the bug goes to the development lead, who then assigns it to an individual developer. So if you're creating an invalid bug and it's the developer who says that it's an invalid bug and you did not understand the functionality correctly, you misunderstood, and that's why it's not a bug, you have basically wasted so many people's time. So it is not a good practice to basically raise a bug that is invalid, and we'll talk about when a bug becomes invalid and all that. So anytime you find a bug, do some research, talk to your team members, and if it helps that you don't know exactly if that's a bug or not, but you see, for example, I found that there's no home page, but I don't know if that's a bug. I don't know if that's how they intended to build this site. So what can I do next? I mean, I personally feel like this is a bug, but I don't want to waste everybody else's time. So I can either talk to my developer or my BA and check, hey, this is what I feel like. Do you want me to raise it or not? And then go ahead and raise a bug. So do some research and try and, to the extent possible, raise only valid bugs. Now, having said that, just because there might be another, kind of philosophy clash here. See, as a tester, you might feel very strongly that the home page needs to be there. But for some reason, if the business analyst says that, hey, there's no need for that, just leave it alone, go ahead and raise it all the same. Again, I'm not trying to be, I'm not telling you to be, defiant or a rebel or anything like that, but as testers, we have to stand for what we believe in. And if you feel like there is a case for, if you feel like there is a scope for enhancement, go ahead and raise the bug. What's the worst that can happen? It will come back to you saying that it's been invalid. But at the end of the day, we need to feel satisfied about whether or not we did our job. So I would recommend creating a bug even when, nobody thinks it is. But what I would not recommend doing is taking it forward and making it a personal fight. And I know that we are all matured enough to not do that, but the reason why I mention this in every class is because every interview that I take, one of the questions that I ask is, what are the challenges you faced in your career? And the answer 100% always is that the developers did not listen to me. They were very headstrong about the bugs I raised. They were never ready to accept that they did a mistake. Now, why would anybody do that? Because we are all working as a team. Developers are also part of the team. At the end of the day, we are all looking at the common good of the product that we are all collectively, perfecting. We are in the process of perfecting the common product. Now, the problem is that, we get too personal. The developer-tester clash is no longer the developer-tester clash is no longer something that we should glorify or gloat over. That's actually bad attitude, and never actually quote that you did not get along with the developer. That's a big black mark. And try to get along. Actually, in reality also, there's no need to fight with them. There's no need to become very defensive about our bugs. If they don't want to accept it, they don't have to. As long as our duty stands, we have to try and, report valid bugs. Whether they want to take it or not, it's up to them. Because when you create a defect, it will have its unique ID. It is trackable, traceable. So when you've done your work, when you have something to prove for what you've done, what is the point of taking it further and, making it into a heated argument? So try not to get to that state. And then the next thing is, Tina says, is reporting invalid bugs, is it a black mark for testers as an employee? I heard this new rule in one of the, clients here. They have a policy, they have a SLA, service level agreement, that if the companies report, if actually it's a client, they are a courier client, and then there is the, another firm who's doing testing for them. So it's a third party testing team for them. So they have this agreement that if you report more than a certain n number of negative invalid bugs, then the company has to pay a penalty. So it's definitely a black mark. But as I said again, this is a thin line between following your job as a tester and actually finding just the valid bugs. So to the extent possible, do a good job and do what you feel about it, not worrying about invalid bugs. But when you're careless, then the invalid bugs is going to be really, really huge. Um, So, which brings me back to Emilio's question, how can an enhancement suggestion be a defect before it is valid? Oh, yes, this is actually a good point. See, defects do not necessarily have to come up after the application is built. So defects can happen. Defects do not necessarily have to um, belong only to the test execution phase. They can belong to test design phase, they can belong to test documentation phase, test planning phase, they can even belong to the define design, all the phases of the SDLC also. So anywhere in the SDLC, if there's a documentation inconsistency, you would just raise a defect and deal with it. It does not have to be in the test execution phase. So yes, that is the static testing and that will result in bugs and you can go ahead and put it out there. So before it is validated by BA, client, and PM, how can it become a defect? See, defect does not necessarily mean that something is wrong. Defect just means that, hey, this is something that needs attention. So you're just grabbing everybody's attention and seeing, making sure that there is a documented reference for it. But come to think of it, if you have an environment suggestion, so enhancement suggestion, where else do you think we can put it? I mean, we have discussed a lot of documents, we've discussed a lot of processes. Do you see like there is any other better fit? Where do you think it can go? Do you think it can go in the test plan? I don't see that happening. And then test cases, no. So when there is really no right place for this kind of suggestions to go other than in the defects. Agreed? Great. All right, Emilio, you take your time with that. And then if you still have a question, I'll be happy to take it. So yeah, let's talk about how do we report the defects. So I was telling you, do your research, be absolutely sure before you raise a defect. Defects will have defect IDs just like everything else, and then a defect description. So defect descriptions are like, one-liner definition of what the problem is. And then there is the steps to reproduce, severity, screenshot. So these are the 5 columns in a defect report. So defect management is normally not done in a manual based Excel report kind of a situation, but if need be, this is something that can be done manually without the help of any external tool. So we'll first learn the process on how to do it manually, and going forward next week we'll see a lot of defect management tools. So I'll show you how defect management is done via a software system. So defect IDs don't generally have any structure or anything. They are simply serial numbers, and defect description is a one-liner pointer of what the defect is. So basically you're giving a heading to your defect. A few rules when you're writing the defect description is that be clear and concise and complete. So you have to really think about how you want to define your defect. So let's take the example of the home page link not being there for the administrator to actually go back and see what featured cards that he has set. So that's the defect we're going to report here. So take some time. I don't, I mean, anybody will not get it right on the first go. So I'm going to try first. So what I'll say is admin has no way Do you think that communicates that Clearly, team? Yeah, so take your time with the defect description. Think of possible ways in how you can, clearly state the defect that you have. There's no guarantees that you'll get it right in the first go. Take some time with this, definitely. And this is something that we are sending it out to an external team. That is something that we'll have to remember absolutely every single time that we create a defect report. So defect report is one way where we can extend the courtesy of providing as much information to the developer as they need in order to isolate a defect and then be able to work on it. So whenever you're providing something, so this is a rule of thumb that I always, state to either the participants of the class or any other corporate trainings that I do. When you are sending out information, don't make the other person ask for more. When you are the one who is receiving the information, take the time to follow up and get it. So the communication, do not be a block to a communication channel that is already in place. So if you have to give generously. If you have to take, ask nicely. So do the same thing with defects. So when you are creating defects, remember that this is information you're providing to somebody else. So generosity again here, include as much information as you possibly can. So steps to reproduce are detailed step-by-step operations that you have performed in order to arrive at this defect. So the very first thing I did was, so this is similar to your test case step, but then the only difference here is that you would not be writing the expected result step to step. So you would launch the Gargoreji site, you would click on admin login from the left hand side. I see your question, Emilio. I'll just come to it in a minute. And login using the credentials. So do not assume that the developer should have the credentials. Sometimes the credentials will differ from environment to environment. So in the development environment, it might be dev 123. In the QA environment, it might be admin 123. So there are different credentials that people use in different environments. So be sure to include that. So yes, in this case, we are assuming that the home page is in the FRD document, or you might actually, use it as an enhancement suggestion. So I'll show you how we can make that differentiation. So log in as admin and then set the featured cars by checking from the desired cars from the list. I think there should be one more step before this, which is click on featured cars link or tab from the left hand side admin menu. Set the featured cars by selecting them, click set as featured cars, and then here what did you expect? To see the result, admin has to go back to the home page. So if it is an enhancement request, you will include the line something like that. It will enhance the experience if one was present or something like that. Or if it is something that is already present in your BRD, the page number, so and so 6 or 7 of BRD states that the home link is to be present. So depending on what kind of defect you're raising it, make sure that you write it appropriately. That's all there is to it. And do your research before that. So go ahead and check your, BRD document. So provide all kinds of evidence, any and all evidence that you can think about. Actual result is that to go to home page, I click on, I launch a new browser instance and restart. So this is the expected result, and this is what is actually happening. Now severity. Severity, to set the severity, common guidelines have to be agreed upon by the team initially. So these guidelines you will find in your test plan document. So here there is a severity table. So you can set the severity as 1 or critical. So help me out here, team, work with me. We'll set the appropriate status for the bug that we have just raised. This bug is critical enough to crash the system, cause file corruption, or cause potential data loss. It causes an abnormal return to the operating system. It causes the application to hang and requires rebooting the system. So does the defect that we raised fit into this category? Yes or no? No, so it's not a critical defect. Next, we'll see if it's high. It causes a lack of vital program functionality with workaround. Yes or no? Is there any loss of functionality here? Again, it's up to your perception. If you feel like some loss of functionality is happening, you still have a choice to go with yes. But I feel like, nothing is lost. All I'm having to do is just, start again. So I will still not go with 2. But this differs from tester to tester. For some testers, this is like, a defect that we absolutely do not want to live with. For some testers, this is not that big a deal. So stay true to your personality. If you feel like this is an high defect, go ahead and create that. The worst that can happen is that the developer will reduce the intensity or severity. That's all that's going to happen. But then be expressive enough to let your opinion be heard. Next is the medium defect. This bug will degrade the quality of the system. However, there is an intelligent workaround for achieving the desired functionality, for example, through another screen. This bug prevents other areas of product from being tested. However, other areas can be independently tested. So yes, as most of you have appropriately said, I also agree that this is a medium severity bug. So I'll come back here and set the severity to medium. So setting the appropriate severity is also a very important step when it comes to defect reporting. And finally comes the screenshot. So screenshots sometimes, depending on the SLAs that your company has, are mandatory for all bugs. So let me show you if this point is mentioned anywhere or not. See, here in the test plan, the testing team has set a guideline that all defects would come with a snapshot JPEG image format. So all the defects, whenever you encounter a defect, it is mandatory to attach a screenshot pertaining to that defect. I know most of you know this process already, but those of you who don't, so this is the page that you want to highlight and say that there is no home button here. So what I would now do is, if this is the page I want to show the developer, I would first do a print screen. So print screen is, the button on your on your keyboard that you'll have to find. Then what I normally like to do is I just take a Word document and I paste it here. But if you need to get a JPEG image, I would recommend going into Paint or Paint Plus or something to that effect. Copy this and then save this document. So while you're saving, also choose an appropriate name. So if you are doing that in Word, also choose the appropriate name. So it's only a matter of preference. There is no rule that you have to use Word or you have to use JPEG. Find out the format that your project is using. Anything can be used. So once you have saved the document, the way you can embed that into Excel is choose the cell where you want this to go. Go to Insert, Object. Then I would go to Create from File, Display as Icon, and I would browse for the file that I have created. So I'll first attach the you know. So there you see my file is displayed, my defect is displayed. If I have to attach the Word document, you just have to follow the same steps. Choose the cell, create from file, display as icon. Choose the appropriate document, say OK. So this is how the Word document gets displayed. So every screenshot should follow, every defect should have a screenshot. And also anywhere data is required, anywhere expected result is required. So if there's a reference to a BRD, or for some reason if the database goes down around 9 or 10 a.m. in the morning because everybody's accessing the timesheet application. So if the time of the day is relevant, any information that is relevant in order for you to express the defect better, you should be incorporating that in your defect report. So which brings me back to Emilio's question. Defects detected and reported directly from test cases have to be included here too. We have a separate for that, right? Yes, we do have a separate status report for that. But remember, in the status report, we just write what module has passed, what has failed. And test case document, we don't share it with everybody else on a daily basis because let's face it, there might be thousands of test cases. If you just send that test case document with test steps and failed, and if you send it across to the developer, it'll be hard for them to filter out. So irrespective of having all of those documents, we still create a separate defect report. It is separate from all of that. There is still going to be there. And there is no category defect kind of column usually used in this report, or is it simply implicit in description column? In your experience, would this not enhance communication? It would definitely. Now, my process is to just give you the bare minimum. This defect template can be expanded or contracted as you see fit. So if you want to include the category of the defect, if you want to include the responsible tester who has found this defect, or if you want to include the module of the application where you exactly found this defect, yes, all of them will definitely enhance communication when used in this template, sure. But was the answer to your previous question clear about the test plan and all that, about the test case document and all that? So all of these are additional optional columns that you can incorporate. So once all the defects are raised, these defects, as we've seen in the defect tracking process, again check your test plan to see exactly what process is being followed. You would go here. Defect tracking and reporting, and you would follow. So the pass fail report and this report are for different audience. Yes, this is actually mostly for the development team to actually act on the defects and start working on it. So we do attach this with the bug status report. We will attach this with the status report, but it may or may not be useful for everyone. It's still exclusively aimed at developers. So once the defects are found and that you've reported, you will send them to your test lead. Usually the process that is followed is at the end of the day, the test lead will validate all the defects that you have. So when I say validate, the test lead will do the following. They will try to reproduce the bugs and see if we have enough information, and they'll check if this defect is a duplicate, if in case, because even though we clearly divide our territories, like admin is going to be worked by team member A, something else is worked by team member B, and things like that. There is also we cannot also rule out the possibility that those two members will identify the same bug. So when the same bug is identified, there's no point in repeating reporting them twice. So if there is any duplication of defects, that is eliminated, and correctness, and whether or not it is actually a defect or the team member has misunderstood the functionality, correctness, accuracy, completeness, functionality wise, whether it is correctly interpreted or not. All of these things the QA lead will make sure, again, to the extent possible. See, let's say on day 1 or day 2 of testing cycles, which is usually when there is a maximum number of defects identified, you cannot expect the team lead to actually verify and validate an entire team's work in a matter of a few hours. So the team must be working all day. There might be 4 or 4 people. They might be raising lots of defects. At the end of the day, it's not possible, like, it probably is possible, but might not be optimum that the test lead will be able to validate it 100% and give you accurate results every time. So even though the test lead tries to do best, even sometimes duplicate defects might create, but actually, go to the development team. Duplicate defects might go to the, you might not even include enough information. So no matter how many points of checking that we incorporate, there is still a scope of things going wrong. So the due diligence has to be done at every team member's level and make sure that, we are not creating an overhead for the test lead. So what I'm trying to tell you is that we should be responsible for our individual work. At the end of the day, no matter how many precautionary steps we take, there will still be like, invalid defects that, still will go to the development team. So that's a risk that we should all be willing to live with. So yeah, next they go to the development lead. Now, why do they go to the development lead? Why can't we directly assign to, developers? So is it possible that 2 testers find the same bug and report it to the TL? It is, but if you can avoid that situation by talking to your team members before you raise that bug, that will be better. But sometimes I admit it is not possible. So it can definitely happen. So my question was, why are we sending the defects to development lead instead of directly to the developer? The reason why we don't do that is because, see, when the development is all done and the QA begins, the development team thins down. There will be like 1 or 2 developers who are responsible for bug fixes. The rest of them, they move on to the next assignment. So as the development when we really don't have an insight on who is going to work on bug fixes and what kind of schedules are they maintaining. So the best person who can, who has an idea on all those things is the development lead. So that's why we don't directly assign them to the developer. We assign them to the development lead. However, if your project just has 1 developer, then, there's no need to have a lead in the middle. So the developer will then fix the issue, and then they will retest the product. And once they retest, once the developer fixes the defects, they will send these defects back to the testers, and the testers will retest them and decide whether the issue is closed or if we need to reopen this defect. So what I mean, when I keep saying send the defect, are you wondering how? So the sending and receiving all of this happens via email and through this Excel sheet. Now, having said that, that is not a very efficient method to do that. See, I'm sending this to the developer. The developer will send this back to me. What do you think he's going to make changes to this? Can he let me know that, hey, I accepted this, I'm working on it? So keeping this kind of a static document is not going to be very productive, correct? So that is why there has to be additional amendments that we need to make this document in order to know what is being happening on this bug from time to time. So the one characteristic of defects that is prevalent across all environments is that defects go through multiple owners and multiple actions being taken on them. So once the defect is created, this is done by the QA team members, whoever has identified the defect. And the action is that, the defect is being identified and you are actually reporting the defect. So reporting, logging, creating, raising an issue, all of them mean the same thing. So different teams, say it differently, but all of these actions mean the same thing. Now this goes to the QA lead. The QA lead will review. This again goes to the development lead, and these people will assign. And the developer will start working on it. So work in progress or in progress, correct? and then the developer will also fix the issues. So their work is done, which means the next owner becomes the QA tester. So Emilio's question is why after they are not approved, why are we sending it to the development lead and not to the test lead? Because the test lead has already validated that it is a valid defect. So what is the point of sending them one more time? Because it is validated already, it is a valid defect. So we can directly just send it to the development lead who will take it forward. And also the diagram that you're seeing is not set in stone for all projects. If you feel like, if you are the one who's, leading a team, and if you want to all the, not approved defects to come back to you, then you can actually change this plan and process and implement it in a different way. But again, I don't see, a real use value to that. So I feel like this is, good enough. So again, the defects go back to the QA tester. So what will the QA tester do at this point of time? They would retest. So once they retest, there are two ways this can go. One is it is a valid. So what will the QA tester do in case it is approved? That means the defect is fixed already. Then you would close the defect. Otherwise, the QA tester, this defect goes back to the development lead and gets reopened. So again, once it gets reopened, all the steps happen again. So the development lead will again assign, the developer will again work, the QA tester will again retest, and then approve, fix, and all that. So you see, one thing that is common across all, the most important observation that we will have to make pertaining to defects is that they change owners, they change actions. So this bug report at this point of time is not flexible enough to show us clearly who is the owner at what point of time and what action is being taken. And to enable that, there is a status field that is added to the bug reports. Now, status field usually denotes who is an actor and what kind of action is being taken. So once the QA team reports a new defect, the status of this defect will be in new. So you'd create a defect, you'd set the status to new. You'll send the email to the okay, let me try and do that and show you. I'll set the status field. I'll remove these two. So I'll set the status to new, and I'll email this link, this defect to my test lead. My test lead will now review this defect, and when they feel like, this review is correct, they open this defect. They set the status to open, right? And then they send it to the development lead. Once the development lead takes a look at this and finds the developer, the status becomes assigned. And once the developer starts working on it, the status becomes fixed, in progress or work in progress, anything like that. And then once the defect has been fixed, the status moves to resolved. And once the QA tester gets it and is reworking on checking whether or not the bug is fixed, the status goes to retest. And it's approved, the status goes to closed. Otherwise, the status is reopened. So status is a field based on which we will track the defect. And that's a good question, Emilio. What if the development lead or the QA lead that decides that it's not a valid defect? That's a good point. We will come to that later. But let's say the developer has started working on it, right? They have come to the in progress state and they're trying to fix it. And the happy flow is that they will resolve the issue. But there might be other alternate flows, correct? They might find this to be a duplicate. They might find that there is not enough information to work on this defect. Or they might feel like this issue is not reproducible. Or they might figure out that this is going to be dealt in a future release, deferred. Or they might realize that this is, working as per requirements and that the QA team has mistaken that it is not. So, this can be done either at the development lead level or the development level. Now, on the other hand, if the QA team figures out that any of this is, not satisfied, we will simply not report the bug. So, in that case, the QA team, the bug will not leave the QA team's, ownership. So if the QA lead finds out that these invalid states are applicable for the bug that a tester has reported, then the bug will simply be deleted from the list. But in case it moves to an external team, development lead or developer, and they figure out that it's a duplicate, or they do not have information, it's not reproducible, that it's deferred and it's as per requirements, then it is sent back to the QA team. And the QA team, so see, resolved status has two implications. One is that the bug is fixed, right? So this is the valid implication. The other invalid implications are these. So in any of these cases, the bug will be set to resolved, and then there will be a resolved valid and resolved invalid. See, resolved just means that the developer is done working on that bug. And when are they done? They are done when it's fixed, which is the resolved valid, and they are done even when they are not able to do anything on it because of all of these invalid reasons. So when it is set to resolved, the ownership now moves to QA tester, and then they will do a retest. So if it is fixed, you'll retest it. If it is any of these states, so if it's a duplicate and the QA team agrees that it's a duplicate, you'll simply close it. If there's not enough information, but QA team can provide information, so you'd again reopen the defect, provide more info, and assign it back. Not reproducible also. If you agree with the status that they set, if you are also not able to reproduce the bug, and you don't know if it's going to come up or not, you can close it. Or if you know that you can provide more information in order to help reproduce that bug, you can provide more information, and in that case you can reopen the bug. So when it's deferred, there's nothing we can do. We just have to leave it alone like that. So if the developer has said that it's working as per requirements, again you will reevaluate. And if everything is fine, you will, so if you agree with their conclusion, you close the defect. If you don't agree, you reopen the defect, providing more information. So these are, the different actions and different ownerships, different statuses that are set during the life cycle of a bug, and that is why this is called the bug life cycle. So the bug life cycle, I'll draw the diagram. Of course, I'll send you a cleaner, better one in the email today. So it starts with the bug being reported by the QA team member and the bug starting at the new phase. Then it gets validated and goes to the open phase, and then it goes to being assigned, and from the assigned status it moves to in progress, or work being done on it, and then to the resolved status. So the resolved can be valid or invalid, which means the bug can be fixed or any of those invalid statuses being acquired. And then the bug goes to retest phase. Here as testers we have a choice to close it, which means that we agree with the conclusion that the development team has provided, or we have an option to provide more information or to actually contest the decision that the development team has made, in which case we reopen the bug and reassign it to the development lead. So this is the end-to-end flow from the time defect gets created to the time defect gets closed. So this is a bug life cycle. Any questions, team? Everything makes sense so far? All right, great. Now, one question I have for you. So let's say if there is a bug that, you've seen a few times, but you don't know the exact steps that are, resulting in it. You've tried that time and again, but you still don't, you're not able to, reproduce that bug. But you do have a screenshot to show that, that bug did exist. So in that case, do we report it or we don't report it? We report it, yes. So sometimes, we probably are not exactly sure of what's happening, but then a bug is a bug. If you've seen it, even though you know that it cannot be reproduced with 100% certainty, the next time you try to do the same things, you will still go ahead and create the bug. What is the worst that will happen is that the bug will come back that it's an invalid bug. And also care has to be taken that not a lot of bugs come back to us, because that's a negative implication. See, it shows that we are not being serious about what we do, or that we don't know what we are doing. All of these implications, negative implications, result from bugs coming back to the QA team with an invalid status. So that is something that we have to take absolute care about. And today's assignment, don't worry about the status column, but try and create at least 5 or 6 bugs. I mean, CarGuruji has plenty of bugs. There will not be any shortage. So try and log your defects in this sort of a template and send it to me. And do not forget incorporating the screenshot, please. That's a mandatory step that we should practice going forward. And there's one other small detail about defects that we need to talk about, and that is the priority. So let's say you've reported 10 defects in a particular day, and all the 10 defects went to the developer. Do you think the developer will start fixing this in the order in which they have received these bugs? So do you think they'll start with the first bug that got reported first and then go in that order? That probably is not very smart, isn't it? So the developers also will do a little bit of an analysis to decide which one they want to pick first. And Padma's observation is right, according to the severity. Now, so if for example, a user, it's a banking site, and the user is performing the transfer, and this transfer fails, which is a severity 1 issue, or the transfer passes, but this is causing some kind of a data corruption, or a compromise in the security, which are also very critical. So critical, very, very critical. This is because of which the functionality fails, and then this is also critical. So in cases like this, when severity is high and this is causing an impact in the customer facing scenario, then the priority becomes 1 as well. So severity and priority in most cases are dependent on one another, but pay attention to most here, because it's not always the case. Let me give you an example when it might not be the case. So let's say there's a site like Gmail or Yahoo Mail or any other site that has a login or logout. So let's say there is going to be a logout link, and the logout link works, and people are getting logged out, the cookies are not getting stored. Everywise this functionality is working fine, except that the problem is it is spelled incorrectly. The G is missing. Okay, I mean, of course few other are missing also, OUT. So yeah, but then there's a spelling error. So according to our table of severity, this is actually a cosmetic bug, which is severity 5. But do you think the company is going to be happy fixing this last, knowing that the users are seeing something as simple as logout spelled incorrectly? Clearly no. So in that case, this takes priority 1, even though the severity is very low. So severity and priority, 90% of the time they are same, but priority determines the order in which the developer will fix the bugs. So following that rule, priority is set by the developer, severity is set by the tester. They are directly related most of the times, but sometimes they might not be. Make sense? All right. So that's all we will, deal with in the class. And I guess we don't have enough time for UAT, so that's something we'll do Monday. That's not an issue. So work on your assignments. Really, I recommend getting as much practice as you can on the, defect reporting process. And the rule of thumb with the defect reporting is that provide too much information. Too much information is always better news than too little. So go ahead and include as much information as you can. I'm yet to get to Merin's and Alka's assignments. I'll do that in the next few hours, and I'll send the comments very soon. And I still and I think Tina's questions on Tina's questions on test plan, I answered most of them, but if you don't have them and if you have further questions on test plan, send me another email. And defect reporting, is it a part of execution phase still? Yes, because that's where most of the defects are found, correct? So yeah, it is. So with the defect management, we are mostly done with the test execution phase also. However, that does not mean that we are done with the test phase of the SDLC, because UAT is still there. So with the UAT, we'll mostly finish all the manual testing concepts, and starting next week I'll show you. I'm planning to start with Bugzilla, which is a defect management tool, and show you how the exact same defect creating and tracking and the whole bug life cycle is implemented with the help of another software. So that's going to be interesting. Sure, Tina, you can send me your previous assignments anytime you get to them. So that's not going to be an issue. So next week we'll see Bugzilla, Jira, QTest, which is a similar tool to QC, since we have stopped, doing the QC in the class. But then I'll send a recorded session to QC so you all can take a look at that as well. And following week we'll do automation testing, and then the career guidance and all that. So that's how we're going to plan out the next 2 weeks. Any questions, team? We do have some time today. All right, then if there are no questions, I'll just send out the notes. I'll send out what exactly is a test cycle. So test cycle is software testing life cycle, everything, the test planning, the test documentation design, and then or if you're talking about the test execution cycle, they are just phases in which testing happens. So test cycles are, see, if you have like 100 test cases that you need to run on your application in version 1, and you have actually estimated that this is going to take 5 days. So the first cycles or the first round of testing, so this is just a round of testing. Yes, 100% is covered. It differs from team to team. Sometimes it is the 100% functionality in every cycle, or they might choose a iterative approach. So in cycle 1 they might develop like 5 requirements. In cycle 2 they might actually do 5 plus 5 and the bug fixes. So in that case you'll have one more round where you will test the final application. So basically test cycle ideally should be 100% all the requirements, unless there are some complications which prevent us from doing the 100% test coverage. So round 1 is when you will test all of these 100 test cases, and then you will send them in round 2 again. You will test all the 100 test cases one more time. That means regression, and you will test or retest all the bugs that were found in round cycle 1. So test cycle is nothing but a phase of the testing where entire testing actually happens, and then where you will identify defects, report and all that, following which there will be another cycle. At least 2 cycles are recommended where you repeat yourself again, do the 100% testing, and this is like a reinforcement to make sure that you are testing as accurately as possible. Padma, can I send the course assignments after the course completion for review? Absolutely. We have a 100% email answering policy. So if you send me an email anytime, right now or after the class, or a year down the line, you'll still get a reply from me. Having said that, the current batch is always a priority because they're waiting on my inputs to actually move further. So that's why I always make the current batch a priority. So if you send me your assignments after the classes are done, I'll still review them, but you might just receive the replies from me after a day or two. That's all. So you'll all receive the invite for the next week's session in a day or two, team. And then, yeah, please work on your assignments and see how you feel about defect management. So I'll stop the recording and hang around for a few minutes.